Okay, so we got this situation. Let f of x equals to ax plus b and gx equals to cx plus d. A and c are not equal to 0. We have to take care of these conditions. Assume a as 1, b as 2. So if a is already 1, why they have given not 0? I don't know. I think they are trying to make sure that f of x is a linear function. Same, c of x is a linear function. Okay, assume this and this, and they are saying that f of g of x is equal to g of f of x. Then what can you say about c and d? Means you have to pass comment about c and d. So let's go with f of g of x. So first component f is f of g of x, and second component is g of f of x. Now be super slow. Look at this. You have to replace x of f of x with g of x. Okay, means you have to write a, then g of x plus b, and in this part, in the function g, you have to replace x with f of x. This means c times f of x plus d. Okay, now apply the replacements. So who is g of x? G of x is cx plus d, and then we have b. Now c times f of x, who is f of x? It is ax plus b, and then b. Okay, now let's open this bracket. So it is acx plus ad plus b equals, it was d, bro. Okay, plus acx plus bc plus d. Okay, now look at this. We have acx, we have acx. So these two things will be neutralized. Okay, now we know that a is 1, a is 1, b is 2. Okay, so can I write d plus b equals 2c? B is 2. Yes, 2c plus d. Okay, now this thing gone. So we are left with b equals to 2c. B was 2. Wait, b we have 2. So we can replace this with 2. So value of c becomes 1. Okay, so we got value of c as 1. Now d, d can take any value, any constant value. Okay, any constant, or it can take any arbitrary constant. So all d are acceptable over here. Okay, I hope this part is clear to you guys, and I wish you guys can handle similar situations. Okay,